Good morning students. Class 12th, chapter number 5, lecture 12 homework and lecture 13. So today I am going to discuss one question from your homework part, question number 5 of exercise 5.8. In question number 5, they are asking us to verify mean value theorem. To verify mean value theorem, I told you whenever you get only mean value theorem, go for Lagrange's mean value theorem, where a equal to 1, b equal to 3, we have to find all the c's that belong to 1, 3 for which f dash c equals 0. So first of all, we will see whether Lagrange's is applicable to it or not. Just to see, it is a polynomial function, so it is continuous everywhere for all x belonging to R, which is the set of real numbers. It will be a differential function as well. The reason is all the polynomial functions are differentiable for all x belonging to R. Now, if these two conditions are satisfied, then we can say that f dash c will be equal to f of b minus f of a divided by b minus a. Let us calculate f dash c. When we find f dash x for the function, we get 3x square minus 10x minus 3. This is what we have differentiated it. So f dash c will become 3c square minus 10c minus 3. Clear? Now we will find out f of b. What is the value of f of b that we get? F of b means f of 3. Putting this in the equation, we have 3 cube minus 5 into 3 square minus 3 into 3. So what we get? 3 3s are 9, 3s are 27 minus 5 into, you say 3 square is 9, which is 45 minus 3 3s is 9. Solving this, we get 27 minus 45 minus 9. Minus minus will get plus, so we will get 54. So the answer that we get is minus of 27. Let us find f of a, that means f of 1. Putting this, we have 1 cube minus 5 into 1 square minus 3 into 1. So we get 1 minus 5 minus 3. 1 minus 8, which is minus 7. So we now have all the values. We need to put in this formula 3c square minus 10c minus 3 equals f of b is minus of 27 minus f of a is minus 7 divided by b minus a, which is 3 minus 1. So when we solve it, let us write it downwards. So when we solve, we get minus 27 plus 7 divided by, here we have 3 minus 1. So we have 2 here. You just see we solve it as minus 20 by 2, which is minus 10. So the equation that we are getting is 3c square minus 10c minus 3 equals minus 10. Once more you can see you got 3c square minus 10c minus 3 equals minus 10. Now we will transpose this minus 10 to another side. We get 3c square minus 10c minus 3 plus 10 equals 0. We get 3c square minus 10c minus 7, which is equal to 0. Or we'll get plus 7. Now, by splitting the middle term method, we can write it as 3c square minus 3c minus 7c. Minus 3c and minus 7c becomes minus of 10c plus 7 equals 0. Now taking 3c common, we have here c minus 1. And here taking 7 common, inside the bracket we have c minus 1. In the complete we have c minus 1 common, one factor. Another factor is 3c minus 7 equal to 0. So two values of c are 1, or another value of c is 7 by 3. Now we need to pick the value that lies between the interval 1, 3. And we know 7 by 3 belongs to 1, 3. Hence the value for c is 7 by 3. So this is how you had to solve your question number 5 of the exercise which was given in your homework part. Now I would like to give you a hint about question number 3. In this question, they are saying f is from minus 5 to 5. So we have a as minus 5, we have b as 5. They are saying it is a differentiable function. You know, every differentiable function will be continuous, because what do we mean by saying a function is differentiable means that every point of the function or the graph of the function, or I say the curve, there exists a unique tangent. That can only happen if it is continuous. So every differentiable function is a continuous function. So both the conditions are satisfied from the first one only. F dash x does not vanish anywhere. Then prove that f of minus 5 does not vanish anywhere means that it does not become equal to 0. That means f dash c is not equal to 0. Then we have to prove f of minus 5 is not equal to f of 5. What is f of f dash c equal to? F of b minus f of a divided by b minus a. b minus a. So we actually have f of b minus f of a, or we can just write in terms of the numerical value for b and a, which are 5 and minus 5 divided by 10. Now what is f dash c? F dash c is not equal to 0. So we will place this is not equal to 0. Solving this, we have f of 5 minus f of minus 5, multiplying both the side of the equation with 10. We get 0 this side. And from here, adding f of minus 5 to both the sides, we get f of 5 not equal to f of minus 5. This is what we had to show. So this was a very simple exercise. Just you need to learn the conditions of Rolle's and Lagrange's theorem. Right, now we will move to our miscellaneous exercise. In miscellaneous exercise, we will discuss some of the questions. The questions are question number 3, 4, 6, 9 and 10 I am going to discuss. Question number 3 is there now. We have to find dy by dx in this. So we will assume y is equal to 5x to the power 3 cos of 2x. Clear? Now as we see it is function to the power function, we can take log on both the sides. We get log y equal to 3 cos of 2x log of 5x. You see there are two functions, so we'll use product rule. This side we will have 1 by y dy by dx equals first function as it is. Differentiation of log of 5x is 1 upon 5x and differentiation of 5x is 5 plus log of 5x as it is. Differentiation of 3 cos 2x, 3 as it is. Cos 2x is minus sin 2x, and when we do for 2x we get 2. So the answer for this is 3 5s are 15, or we can cancel 5 and 5, just write 3 cos 2x upon x plus, here we can multiply 3 and 2, that will be 6. Now you observe here, this is plus and this is minus, sign will become minus. So we can directly write minus 6. Right? Minus 6 sin 2x log of 5x. And here we have dy by dx. So to remove this y from here, we'll multiply both the side of the equation with y. So y will come this side, and we have to just put the value of y from here as 5x whole power as 3 cos 2x. That's the only thing to be done in question number 3. Now let us go to the next question, which is question number 4. To solve question number 4, we'll assume y is equal to sine inverse of x root x. Let us differentiate it with respect to x. When we do it, differentiation of sine inverse of the function, it is 1 upon under root 1 minus x root x whole square into differentiation of x root x, it is d by dx of actually x to the power, this is half and this is 1. So power is 3 by 2. Now this can be solved as 1 upon under root 1 minus, see it is x, so it is, we are solving actually this thing, x under root x whole square. See carefully, it can be written as x into x to the power half whole square, which can also be written as x to the power 3 by 2 whole power is 2. 2 and 2 getting cancelled, we are left with x cube. Clear? And here we'll have 3 by 2 x to the power 3 by 2 minus 1. So to solve this, we get 1 upon under root 1 minus x cube into 3 by 2 x to the power 3 by 2 minus 1. We get x to the power 1 by 2. That can also be written as 3 by 2 under root of 1 minus x cube, and x to the power half we have. So that can be written as under root of x. So this is how we are going to solve the question. Clear? Now let us move to the next question. Question number 6. We have to differentiate it. So let us first simplify it and then solve it. So just to see, here I am solving the expression inside under root. So I'll just show you in rough how do we solve it. Let us take it a proper one. So you see 1 plus sin x is given in the under root. You know, we need to think of the identity that can remove this square root. One thing is you can rationalize, or to avoid that, see under root 1 plus sin x. I'll solve for 1, you will get for all the others. 1 can be written as cos square x by 2 plus sin square x by 2. Now, plus this can be considered as sin 2x and can be written as 2 sin x by 2 cos x by 2. Now this all is there inside the under root. You see a square plus b square plus 2ab. This can be written as cos of x by 2 plus sin x by 2 whole square. Whole square and root will get cancelled up. So we are just left with cos of x by 2 plus sin of x by 2. Similarly, where we have the minus sign in between, we will form a formula of cos x by 2 minus sin x by 2. Let us put these values there. So you will get cot inverse of cos x by 2 plus sin x by 2, because there is a plus sign in between, just now we have solved, plus when we have minus sign, we will get minus 2 sin x by 2 cos x by 2. So formula will be of minus cos of x by 2 minus sin x by 2. This is our numerator. In the denominator, we will have it as 1 plus sin x. So we will write cos x by 2 plus sin x by 2. Now minus of, we have the same thing in negative. So it will become minus cos x by 2 plus sin x by 2 when we apply the negative sign outside the bracket. So you just see, we can cancel sin x by 2 to sin x by 2. We can cancel cos x by 2 with cos x by 2. In the numerator, we are left with 2 times cos of x by 2. In the denominator, we are left with 2 times of sin of x by 2. 2 and 2 will get cancelled. Cos x by 2 and sin x by 2. When they are divided, they form cot of x by 2, which can now be written as x by 2 only. So we have y equal to x by 2. So this implies dy by dx will be equal to 1 by 2 as it is. Differentiation of x is 1. So we will just have the answer as half for the question. Clear? So you need to think carefully what is to be applied to make it much simpler. Right? Rationalization could also have been done. Now let us move to the next question, which is question number 9. Now definitely function to the power function is there. We are going to take log on both the sides. So we have y equal to sin x minus cos x whole power as sin x minus cos x. Taking log on both the sides, we have log y equal to sin x minus cos x will come in front, log of sin x minus cos x. Let us differentiate with respect to x. We have 1 by y, dy by dx equals, as you see there are two functions. In product rule will be used. First function is as it is, Differentiation of log of sin x minus cos x is 1 upon sin x minus cos x. Now we will do for sin x minus cos x. Sin x differentiation will be cos x and cos x differentiation will be minus sin x. So minus and minus will become plus. These will get cancelled. Now to apply the second one, log of sin x minus cos x will be taken as it is and will differentiate sin x minus cos x, the answer for which is cos x plus sin x. Clear? Now dy by dx will be written as equal to, by multiplying both the side of the equation with y, cos x plus sin x, we can take common in this and we have 1 plus log of sin x minus cos x. Clear? Into y. Y value is sin x minus cos x and in the power we have sin x minus cos x only. Clear? So this is how we are going to solve the questions. When we have function to the power function, definitely logarithm is to be used. Let us do one more question of the miscellaneous exercise, which is question number 10. In question number 10, we have been given y is equal to x to the power x, x to the power a to the power x and a to the power a. Let us consider them as u, v, w and let us consider this as p. Now we will differentiate all of them separately. What is u equal to x to the power x? You know it is to be solved by taking log on both the sides. So we have x log x this side, 1 by u, du by dx will be equal to x as it is, differentiation of log x is 1 by x, plus log x as it is, differentiation of x is 1. So du by dx value is 1 plus log x into u. U value is x to the power x, name it as first equation. Now we have to find dv by dx. What is v that we have with us? So let me draw a line to just separate the solutions. Okay, what is v with us? V is given as x to the power a. You know x to the power a, where a is a fixed number. So whenever we have x to the power n, how do we solve it? dv by dx will be equal to a x to the power a minus 1. Okay, let us name it as equation number 2. We have w as a to the power x. Clear? We know that d by dx of a to the power x, direct differentiation we have the formula. So what will be dw by dx? I am writing here a to the power x log of a. This will be the third equation. Let us now solve the fourth part, which is p. You see in p what is given? A to the power a. Correct? So it is a constant number only. So what will be dp by dx? It will be 0. Let us name it as equation 4. So now dy by dx will be given as, by adding du by dx plus dv by dx plus dw by dx and plus dp by dx. Now you know all the four values, you can simply add them and can write the answer. So this is all for today's discussion. The homework questions of miscellaneous are, you will solve question number 1, 2, 5, 7, 8, 11, 12, 13. These are the miscellaneous questions that you are going to try yourself at home and come up with the queries the next day. This is all for today. Thank you so much.